Python was conceived in the late 1980s by Guido van Rossum, a Dutch programmer. Inspired by the ABC language, he started working on Python during the Christmas holidays of 1989. Named after Monty Python, the language was officially released in 1991. Python's popularity has soared, becoming one of the most widely used programming languages today. Its simplicity and readability attract both beginners and professionals. Python supports multiple programming paradigms, adding to its versatility. Its rich standard library supports many common tasks right out of the box. The open-source nature of Python has fostered a large and active community. The Python Software Foundation ensures its ongoing development and relevance in the tech industry. Python is a high-level programming language, abstracting complex hardware details. This makes Python code easy to read and write. It is an interpreted language executed directly without compilation. Python features dynamic typing, adding flexibility. Its cross-platform compatibility is a significant advantage. The Python community is robust and supportive, offering extensive resources. Web development is one of the most common applications of Python. Frameworks like Django and Flask make it easy to build secure and scalable web applications. Django is known for its dry principle and built-in features for authentication, database connections, and URL routing. Flask is lightweight and offers flexibility, making it ideal for smaller projects. Python's simplicity and powerful frameworks reduce complexity, allowing focus on user experience. Data science is a field where Python truly shines. Its powerful libraries such as NumPy, Pandas, and Matplotlib provide tools for data manipulation, analysis, and visualization. NumPy is known for its efficient handling of arrays and matrices, which are fundamental in scientific computing. It provides a range of mathematical functions to perform operations on these data structures, making it indispensable for numerical computations. Pandas builds on NumPy by offering data structures and operations for manipulating numerical tables and time series. It is perfect for tasks like cleaning data, transforming it, and performing complex data analysis. A data scientist can easily load datasets, process them, and extract valuable insights using Pandas' intuitive API. Matplotlib is a plotting library that enables the creation of static, interactive, and animated visualizations in Python. It provides an object-oriented API for embedding plots into applications, making it an essential tool for data visualization. Whether you need to generate simple line graphs or complex 3D plots, Matplotlib provides the capabilities to display data effectively. Python's versatility and ease of use make it a favorite in the data science community. The language's ability to handle large datasets combined with its extensive library support makes it an essential tool for data scientists working in various sectors from finance to academia. Section 5: Python for automation and scripting. Automation is another area where Python excels. Its ease of learning and powerful libraries make it a popular choice for writing scripts to automate repetitive tasks. Python's OS and sys modules provide functions to interact with the operating system, allowing developers to automate file and directory manipulation, as well as system processes. The Python package PyAutoGUI enables developers to programmatically control the mouse and keyboard. This is particularly useful for automating tasks in a graphical user interface environment. Whether it's filling out forms, downloading reports, or scraping data from web pages, Python scripts can save significant time and reduce the potential for human error. For network automation, Python's Paramiko and NetMiko libraries allow developers to automate tasks involving SSH and other network protocols. This capability is particularly useful in managing network configurations and monitoring network devices. Python's extensive standard library, combined with its ability to integrate with other technologies, makes it a powerful tool for automation. By automating mundane tasks, developers can focus on more strategic projects, boosting productivity and efficiency. Section 6: Game development with Python. Python is not just for data science and web development, it also has applications in game development. Pygame is a cross-platform set of Python modules designed for writing video games. It includes computer graphics and sound libraries, allowing developers to create fully featured games with Python. Pygame provides support for creating two-dimensional games, which is a great starting point for beginners interested in game development. It offers functionalities for rendering graphics, handling user input, and managing game states, which simplifies the game development process. Developers can focus more on game mechanics and design rather than dealing with low-level programming details. In addition to Pygame, Python's simplicity and readability make it an excellent choice for writing game prototypes. Rapid prototyping in game development is crucial, and Python's ability to quickly iterate through code allows developers to test and refine game concepts efficiently. Despite being less common for large-scale, high-performance games, Python's role in educational and indie game development is significant. It allows aspiring game developers to quickly bring their ideas to life and learn about game development concepts without the steep learning curve associated with other programming languages. Section 7. Python in Scientific Computing and Finance. Python's role in scientific computing is significant, largely thanks to libraries like SciPy and SymPy. SciPy builds on NumPy and provides additional functionality for optimization, linear algebra, integration, and differential equations. It is widely used in scientific research due to its efficiency and ease of use. Scientists and engineers can model and solve complex problems using Python, taking advantage of its extensive library support. SymPy, another valuable library, is used for symbolic computation. It can perform algebraic operations, solve equations analytically, and simplify mathematical expressions. This is particularly useful in fields like physics and engineering, where symbolic computations are often required. In the finance sector, Python is used for quantitative analysis, risk management, and algorithmic trading. Libraries like Pandas and NumPy are extensively employed for handling financial data and performing complex numerical computations. Python's ability to process and analyze large datasets efficiently makes it a preferred choice for financial analysts and institutions. Python's versatility in scientific computing and finance demonstrates its capability to handle both symbolic and numerical computations. Its comprehensive library support and ease of use make it a powerful tool for researchers and financial professionals alike. Section 8. Artificial Intelligence and Python. AI and machine learning are exciting fields where Python excels. Libraries like TensorFlow, Keras, and PyTorch make Python ideal for AI. TensorFlow by Google is an open-source library for machine learning. Keras simplifies building deep learning models with an intuitive API. PyTorch by Facebook offers dynamic computation graphs for flexibility. Python's simplicity and vast ecosystem make it essential for AI development. Section 9. Starting your Python journey. Embarking on a journey to learn Python is both exciting and rewarding. As a beginner, the first step is to familiarize yourself with Python's basic syntax. Understanding control structures like loops and conditionals is essential, as they form the backbone of programming logic. Functions and data structures such as lists and dictionaries are also fundamental concepts that you will encounter frequently. Object-oriented programming, or OOP, is another important concept in Python. Understanding how to create and manipulate objects will allow you to write more organized and modular code. Python's OOP features are straightforward to grasp, making it an ideal language for learning this programming paradigm. There are numerous resources available for learning Python, ranging from online tutorials and courses to books and community forums. Websites like Codecademy, Coursera, and FreeCodeCamp offer interactive Python courses for beginners. Books like Automate the Boring Stuff with Python provide practical exercises that make learning engaging. Joining the Python community can greatly enhance your learning experience. Participating in forums like Stack Overflow and attending local Python meetups are excellent ways to gain insights and support from other Python enthusiasts. The Python community is welcoming and eager to help newcomers, making it a valuable resource for any aspiring programmer.